Instead of trying to decarboxylate the glucuronic acid residues, I might be able to reduce them to glucose residues. All chemists know that if you want to reduce the carboxyl group in benzoic acid to give benzyl alcohol, you use lithium aluminium hydride in dry diethyl ether or dry tetrahydrofuran. But these polymers are insoluble in diethyl ether or tetrahydrofuran or any other ether solvents. Okay? Acetylate the free hydroxyl groups in the polymer. In 1945, Carson and McLean, the United States, showed how this can be done. The polymer is dissolved in formamide and then react with acetic anhydride and pyridine. And now you've got the acetylated polymer, which is soluble in diglyme, which is an ether solvent. You could use lithium aluminium hydride reduction. No. The reason why this won't work is because acetates are esters, and lithium aluminium hydride will reduce esters faster than carboxyl groups. So as soon as some of the acetyl groups are removed, the polymer falls out of solution and the carboxyl groups remain unchanged. In 1955, Alistair Stephen was working in the chemistry department of the University of Edinburgh, having gained sabbatical leave from Cape Town University. He was working in the same laboratory as a Swiss fellow called George Zweifel. At the end of this year in Edinburgh, Stephen went back to Cape Town. Zweifel stayed on in Edinburgh for a year, and then he went to work with H.C. Brown at a university in Chicago in the United States. 20 years later, H.C. Brown got a Nobel Prize for chemistry. In 1959, Alistair Stephen again got sabbatical leave, and this time he went to work with Fred Smith in Minnesota. Soon after he got to the States, he passed through Chicago and saw Zweifel. And Zweifel told him that they were investigating the reducing properties of diborane, and the diborane could reduce carboxyl groups faster than ester groups. And Zweifel pointed out to Stephen that this could be a way of reducing carboxyl groups in acid polysaccharides. Stephen told Fred Smith about this, and then early in 1960, Stephen and Smith published a paper in Tetrahedron Letters saying that they'd reacted acetylated gum tragacanth with diborane in diglyme, and after removing the acetyl groups, produced carboxyl-reduced gum tragacanth in good yield. In 1959, Gerald Aspinall was also in the States on a lecture tour, and he saw Zweifel also. And then when he went back to Edinburgh, he told one of his students to acetylate one of the hemicelluloses and reduce the carboxyl groups with diborane. These compounds are similar to the gums in that they have a long chain, this time xylose, and they have side chains ending in uronic acid for methylglucuronic acid. When the student tried out the reaction, he found that the carboxyl groups were not reduced. Okay, if you want to do a diborane reaction, this is what you could do. You could connect up two flasks, A and B. In flask B, you have a solution of the acetylated polymer in diglyme. That's where you want the reaction to take place. In flask A, you have a solution of sodium borohydride in diglyme. At the top of flask A, you have a Y piece. Connected to the top of the Y, you have a separating funnel containing borotrifluoride in ether. And the other arm, you have an ordinary tube which connected to a nitrogen cylinder. all the connecting tubes, all the glassware, and all the chemicals have to be perfectly dry. And at the end of the apparatus, you have a guard tube containing calcium chloride or silicon gel to prevent moisture coming in from the atmosphere. You then open the tap of the separating funnel and let the boron trifluoride in ether drip into flask A. When it comes into contact with the sodium borohydride, it reacts to form diborane gas, and then you open the valve of the nitrogen cylinder and get the diborane to go from flask A into flask B. There's another method of doing this. In the second method, you dissolve both the polysaccharide acid, acetate and the sodium borohydride in a conical flask. You add a small quantity of the boron trifluoride in ether, fit a rubber bug and swirl the contents of the flask. When this gas subsides, you keep adding another quantity until you've added the lot. In this day and age, it's possible to buy a solution of borane in THF from the Sigma Aldrich company in the United States. I've seen in the literature that about 10 years ago, the Sigma Aldrich company was taken over by the Merck Group in Darmstadt in Germany for a price of $17 billion. I think this is interesting because before the Second World War, the Merck Group had a subsidiary in Rahway, New Jersey in the United States. But when USA got into the Second World War, they confiscated all German companies in the USA, and after the war, Merck remained American. And now the Germans have bought back one of the big American companies. Anyway, at the time I discussed this with Gerald Aspinall, and he persuaded me to use the first method because all the ions that were produced in the reaction remained in flask A, and you didn't have to get rid of them at the end. So I tried this out, and what I found was soon after the diborane got into flask B, the mixture set to a gel and the carboxyl groups were not reduced. And that was exactly the same thing that Fanshawe had found when he tried to reduce the carboxyl groups in his hemicellulose. I think Gerald Aspinall was pleased with my result because when his student could not get the reaction to work, he found that some other people couldn't do it either. But Stephen and Smith had used the second method, so I had to try that. And I found that after about the third addition of the boron trifluoride, the mixture in the flask became a solid. So then I put the rubber bug in properly, shook the flask well, the gel broke, gas started coming off again, and then the reaction worked well. At the end of the reaction, I decomposed the reaction mixture with water, distilled off the dicline, removed the acetyl groups by saponification, removed the ions by dialysis, and poured the dialyzed mixture into 5 volumes of ethanol, and the carboxyl reduced cum arabic precipitated in good yield. A few years after I left Edinburgh, I got a letter from Gerald Aspinall saying that they'd managed to make the first method work as well. They had to leave the mixture for some 3 weeks under diborane pressure.